Hey folks, 9.4. So what we've established at this point is that if we have any problem that looks like this, we can solve it. So quadratic formula, X method, factoring. So we can solve this. No matter what it is, we can solve it. Oh, focus. Okay, so in 9.4, they say, well, if you could do this, there's things that look like that. So imagine, so let's see, plus b x squared plus c equals 0. So you see how this is just, this guy squared is that? So what if we had a x to the fourth? Ugh, I can make a nice 4. 4. Ugh, horrible. A x to the fourth plus b x squared plus c equals 0. So if we can solve these, we can solve these because it's the exact same game. You just sort of pretend that instead of an x, it's an x squared. Okay, so by that same logic, you could have something that looks like this, plus b root x plus c equals 0. You see how if you square this guy, you get that? So right, you square this guy, you get that. Nothing. This guy squared. Nothing. This guy squared. Nothing. This guy squared. And by nothing, I mean no x stuff. Okay, or so let's say a plus b plus c equals 0. Okay, so it's just a matter of recognizing that we're not really doing anything mathematically new. So what goes in here, who knows, maybe it's something, they might put something weird like an x plus 1 and put an x plus 1 there. It just needs to match. So for example, I'll put x minus 5, x minus 5. So this looks just like that. Okay, a lot of rambling. Let's try a problem. Yeah, you might want to write that down. Okay. 9.4. Try 156. It says x, 156. X to the fourth minus 9x squared plus 18 equals 0. So it just looks like, to me, I just see x squared minus 9x plus 18 in my mind, sort of. I'm kind of ignoring that as an x to the fourth and x squared. It has that correct form like I pointed out earlier. So 19, so is that minus, I like factoring, minus 6, minus 3. So that's going to be x, but it's not x, it's actually x squared. It's that middle piece. Ponder that for a second. So that's, right, x squared times x squared is x to the fourth. Minus 3x squared minus 6x squared is minus 9x squared. Minus 6 times minus 3 is positive 18. So if you follow this, you get that. Aha. You seeing it? Good, good, good. And then set each piece equal to 0. X squared minus 6 equals 0. X squared minus 3 equals 0. Oh, I'm going to use that one trick we learned. X squared equals 6. Square root both sides. So x is equal to plus or minus root 6. X squared is equal to 3. Square root both sides. So x is equal to plus or minus root 3. So here's my answers. X is equal to plus or minus root 6 or plus or minus root 3. Root 6 doesn't clean up. Root 3 doesn't clean up. So that's it. Easy, easy, easy. Okay, let's try 162. No, 164. 164. X plus 2 squared minus 3. X plus 2 minus 54 equals 0. It looks just like, here's actually what I sort of see it as. Let's go back to this one. This one looks to me sort of just like, I'm going to use w. W squared minus 9w plus 18 equals 0. And that factors into w minus 6, w minus 3. So this is sort of that. So when I see this problem up here, I sort of see this as a w squared minus 3w minus 54 equals 0, which factors into w minus 9, w plus 6. But you see how w is really x plus 2? So x plus 2 minus 9, I'm just substituting in, and instead of w, I put an x plus 2 plus 6. So that's x minus 7, and that's x plus 8 equals 0. Aha! Is it better if I put extra parentheses? And so I get answers of 7 and negative 8. Set each piece equal to 0. Let's try 172. 172. X minus 8 root x plus 15 equals 0. So the way I see it, it looks like the correct form that I pointed out on that very first page of paper for this video. So this is just w squared minus 8w plus 15 equals 0. I'll factor that. W minus 3, w minus 5. But w is really root x. Okay, set each piece equal to 0. And, oh, let's do that one trick we learned where we square both sides. Ta-da! So x is 9 or 25. Okay. So we only go up to, in this section, I think I said just go up to, is that 94? 177. Yes. Okay. Perfect. And that was 94.